Hello, hello to all. Today we will be discussing about the starting of three-phase induction motor using autotransformer. Before starting this autotransformer as a starter, we will shortly explain what is autotransformer and just simple schematic diagram of autotransformer. Okay. So now see autotransformer. Simply if you see here three-phase induction motor and also autotransformers would be three-phase autotransformer. So as we know the single-phase autotransformer, what it is a single-phase autotransformer. Single phase autotransformer, we know that there will be, if we two winding transformer, there is a two winding transformer. If we make it into a autotransformer, then the primary winding and secondary winding. So if we two winding, if we short it, then we will be getting, because if this winding is variable point, so this winding may be the supply and this winding may be for load. Okay, as similar as what, like a rheostat, like a potentiometer. What is the connection? Potentiometer, resistance. This is the variable point. If variable point may be go for load, connect load. Okay. Now for autotransformer, the same. This is the resistive element and this is the resistive with inductive element. Okay. Because the inductive elements not purely inductive, there should be a resistive, small resistive element also. Okay. So now if this is the configuration of single phase autotransformer, this is the potentiometer, then what would be the three phase autotransformer configuration? For single phase configuration, this is coil and we can consider this is a variable point. Okay, this will be the load 1. Okay, and for three phase, this is phase 1. We could consider one more phase. This is also one more phase. Suppose this one L1, L2 and L3. So this is the variable point. Okay. Now this point, and this point we can consider as a common point. This will go for line. This will go for the line L1, L2, L3. Okay, and suppose here this is supply will be coming. This is supply. Okay, and simply what would be the connection would be the, and this is the common point. this 3-point short at point. This point is maybe you can consider as neutral point. Now obviously it will be neutral point if these space are all in balance. Okay. Now this we can connect to this one line to line. This is main. This is main supply. Okay. And this can connect to this point. This. Okay. So simply what we got? We got actually like this. This will be the variable point. This will be the variable point. And this will be the point. And here there may be supply and this and this point loop or variable point. Variable point means what? Here suppose we are stepping up, we are stepping down. Okay. So how many turns means auto transformer means it is variable transformer. Variable voltage will be giving. So supply, in case of supply line to line 415 you have available. You have 415 volt. Then you are just by varying this point and this variable point, there will be knob obviously. So that variable point smoothly vary or according to the turns smoothly. Means if here 2 times up and down or up and down, up or down. Okay. And here also it will up and down. Smooth for all 3 phase it will be same to get the balance supply. Okay. And phase accordingly voltage also will be same, and accordingly it should be apart from 120 degree phase apart. All three phases. Okay. So these things we will be getting here the auto transformer startup. So suppose startup we would be starting with some voltage, suppose 230. Okay. So here the suppose variable point would be, it may be k greater than 1, may be k less than 1. It may be step up or step down. K means transformation ratio. Okay. So here the one term will be the potential. Suppose potential difference transformation ratio Vs Vp, and at a particular point, suppose at this point it K equal to what, how much, 230 and 450. If supply voltage is 450, I mean you have to see the face to face voltage or the trans ratio, here voltage ratio. Suppose you are considering the voltage ratio. The voltage ratio is Vs by Vp equal to K. If it is in terms of trans ratio, then it would be you have to see that this is the star connection. Then across the phase, how much voltage is there? Here obviously star connection. So line voltage would be phase voltage will be these things. And here how much voltage is coming? 230 suppose. If it is 230, then we have to consider the trans ratio. Okay. Now here the voltage ratio, if simply voltage ratio is given, then line to line voltage and line to line primary voltage and secondary voltage means the load voltage. Okay, that is known as the voltage ratio. Clear? So these things will be accordingly these things is varying. If K is depends on this. Okay, suppose transformation ratio K, yeah, voltage ratio K or K or N, somewhere you will be saying it is an N or somewhere you will be that mention it as a K. Okay, so now see what if current is in terms of this is coming, then if voltage if it is coming as with respect to this ratio is depending, and then current also obviously it is depending on this, because we know that input VA and output VA is equal. For lossless input VA we know input VA equal to output VA for any transformer, so it would be same. Okay, so now these things we can see how this three-phase transformer will work, and it is changing with voltage and also it affects in the current also. Okay, then how it is coming into the effect of this current and voltage both we will be seeing in the starter. Okay, then now here we will be starting with the starter. Here auto transformer starter means it will help three-phase auto transformer will help to start the three-phase induction motor, because we know that if directly if we start then there is a very high current flow through the stator winding, then this dangerously high current would obviously damage the winding. So to limit this current within the capability of that motor or any device, this starter, not only for this motor, you will see in case of synchronous motor also, any type of motor, basically this type of motors who is having the high inertia, that motor is required obviously starter. If there is no inertia, if inertia is zero, then there is no need of starter. Inertia is zero means what? You just switch on okay, just switch on and motor takes the pickup. Okay, that thing happen if inertia of the motor is zero, but it's practically impossible. There would be some load connection, there would be some frictional matter, so obviously the inertia cannot be zero in practical case, so starter obviously there. Okay, now the connection it simply you see, suppose here three-phase supply will be coming from this way. Okay, and here we can put a switch, main switch. We have put a main switch. Clear? Now thing will come. How will we connect? How will be starting purpose and running purpose? How will be operating? These things we have to see. Here I am one coil of auto transformer, here coil, on coil, here and coil. Suppose this is the variable point, this is the variable point, this is the variable point. Okay. Okay. Now these things we have to see what we could do for this. Initially, for the starting, it would be we are starting with this autotransformer here and these things. Now here I am. Let's click this one and this one. There and then it's and there one. This. Okay. And these things will be going to what and winding. This is the motor winding. Motor winding. This is the motor stator, okay, star connected motor. Okay. Now supply we should connect the supply. Suppose here red phase is connect to this point. Blue phase connect directly to this point. Connecting that phase. This okay. This point. Now how it will be operate? If this switch anti-clockwise and this switch this way rotation. Okay. If it is in clockwise means it will be start. Okay, if start process is completed, now will be switch to this as a running condition. This is the start clockwise and running. See the current flow. Firstly, if it is start, then it will be off. These things will be off. If it is start, then what? These things with this it will be short. This point and this point will short, and with this output is coming through this way. Okay, for this in the same way as we previously discussed, this connection of the autotransformer, there would be the output terminal O1, suppose O2, O3, O2, O2, O1, O2, O3. The output terminals. Okay, this one is the neutral terminals. Okay, and here, and if it is already started, then what? The running condition. So this should on and this should disconnect. If it is on, then it will be open. This connection will be open. Then what? How it will be connected? See, this in this short, and what? This way connection. This point and this point, it will shorted this way, and there the supply connection connected with the supply, main supply. Okay, this is the connection of starter. Okay, now see what would happen for this starter. So now the calculation part is there. So if the voltage, suppose we are suppressing the supply voltage V. Okay, that standstill condition means what? Standstill condition means the rotor is not moving. Rotor is not moving. That means blocked rotor. If you see the block rotor test, in case of block rotor test, you might have seen. You will be seeing what? Small voltage you are applying, but dangerously high current you are getting. Means high current you are getting. If under short circuit condition, if directly apply the all voltage, rated voltage, then very high current will be flowing. So that current would be considered as a short circuit current. If under short circuit condition, suppose under block rotor test, if we apply some voltage, not rated voltage, and we are getting rated current. As you know, this thing might simply rated current. Okay, some voltage we are applying, but we are getting rated current. Okay, from that expression, for this voltage we are getting that much current. Suppose for one motor specification 415 volt, 5 HP, 7.5 ampere is the rated current. So suppose 100 volt is there. For this voltage we are getting 7.5 ampere. Now what will be the short circuit current? Short circuit current will be the for 415 volt. So that much voltage, that much current. How much current? 415, and this is the linear proportional 7.5. This much current we can observe. Okay, so what? That much current 415. 415 means 4.15 into 7.5. This much 31.125. this much current. It's just an example, and see, this will be the short circuit current. It's presenting as ISC. But here for this case of study for starter, auto transformer starter. So here initially what happening? Initially happening, and we are setting a point. That point we can setting this variable point. This is the variable point. This is variable point. This is variable point. First we are changing the tap. Okay, by changing this tap, we will be getting the output voltage across the motor. Okay, suppose somewhere we have set. Okay, suppose the voltage is some rated voltage, but k times this. K times we are considering the k is less than 1. Okay, so if k is 1, then we will mean it that we are directly applying this rated voltage. Okay, if it is k 0.5 V, then 50% voltage will be applying. If we are 50% voltage applying, then what would happen? 50% voltage is applying across this voltage, across this terminal, na? Okay, but again for this voltage also the current also proportionally will reduce, na? Current also will reduce. Okay, then for auto transformer starter, for auto transformer as a starter, current will be reducing as k square times of short circuit current, because the current is reducing for voltage. Current is reducing for voltage 1, and also is it would be reducing for, if voltage is reducing, then to maintain the VA, IA, V2, I2. So current, for this current also will reduce, na? So then current also will reduce 1 times. For current is reducing for turns ratio, and voltage is reducing. If voltage is reducing, also starting current will be reducing. Okay, one reason is reducing voltage. Okay, and second is for transformation ratio. Okay, so these things will be getting. Okay, clearly see that this k times k, one time k is for voltage and 1 time k for the trans ratio of transformer. Okay, these things. Okay, and this is current, this short circuit current. This short circuit current is per phase. Okay, per phase winding. Okay. Now if you see the torque equation. Okay, if you see the torque equation, what we can see? The torque equation is starting torque and suppose full load torque. If full load torque, and we know that torque is proportional to voltage square. Okay, torque is proportional to what? Voltage square. Okay, torque is proportional to voltage square is. So here if the starting torque is means slip means is 1 for starting, the full load slip will be SF. So finally will be what will be getting. So for this expression if we see what starting voltage square divided by SF into SF, the full load square, and full load means what? It's operating at rated voltage. The full load. Starting voltage means what? Starting voltage is simply K times of this voltage, and this starting voltage is proportional to the starting current. Okay, for this starting current, so what would be the KISC into full load voltage, full load current into SF. Okay, so this much things we can write. Clear? So simply what is this? K square is 1 ISC, the short circuit current, into IFL square times of SFL is the slip at full load. Slip at full load. So again, if we this term is for short circuit current. Okay, short circuit current means what? At standstill condition or block rotor condition, if we apply simply rated voltage, the how much current will be there, that is the short circuit current. Okay, now in terms of starting current, if we see this expression, so if we replace this SC, I starting divided by how much? K square. So how much we will be getting? K square ISC, if we replacing, then K to the power 4 times I starting and I SFL square. So square 2 times will be available SFL. Simply how what is available? What after cancellation? What will be the expression? Expression will be 1 by K square starting current divided by IFL square into SFL. This expression you should remember in terms of starting current divided by full load with the starting torque and full load torque. Okay, clear? Now what would be the voltage? Torque is proportional to voltage square at starting. Okay, if slip is high, okay, then this would be the inverse. Torque is proportional to V square by slip. Clear? Slip is high. Clear? So if we finalize these things, so what would be, we discuss the connection of the autotransformer. Okay, then how it is working as a starting switch and the running switch. Okay, to for run the three phase operate three phase induction motor. Okay, this would be the connection. Okay, if this connection is for autotransformer, it's for starting purpose, and this would be the for running condition, then it will be isolate, autotransformer will be isolate. Okay, so if start happen and it is settled, then no need of autotransformer. Okay, but only starting case you should require the autotransformer to limit the starting current. Clear? So one more thing here, the autotransformer, if inertia is 0 for any motor, so they are not require any kind of starter, because it picks up at that instant the speed. Okay, so one more thing here, starting current, you should remember the starting current and how this starting current is 1k times is coming for the voltage, and 1 is coming for the trans ratio. 1 is the coming for the trans ratio. And ISC, what is ISC? ISC you may consider as a direct online starter, direct current for direct online starting. If directly you are giving the supply voltage, there are no means of starter, how much current you will be getting? That is nothing but equivalent to the block rotor test. Block rotor test, you are doing block rotor test at rated voltage. Okay, but we should do block rotor test at rated voltage, because dangerously high current will draw. Approximately we can consider that how much to get the rated current, how much voltage we will be giving, proportionally that much for rated voltage, how much current we will be getting, that is known as the ISC, is short circuit current. Okay, ISC means that short circuit current at direct switching, means there is no means of starter. Clear? So I think all the details of autotransformer starter. Here, watch for the next video. Okay, we'll be discussing the starter related numerical problem. Okay, to solve numeric, we will discuss in elaborately the starting concept with one problem, not one problem, one by one, 2-3 problems we will be discussing. Okay, for all kind of we will be covering the all kind of starters to 3-phase induction motor. Okay, so keep watching for next video also. Okay, thank you.